Hello, this is now part 2 of my vlog. I just got back from a banquet and this is why I'm dressed up, for the organization that I'm a part of at school called University Program Board. And being at the banquet has inspired me to start talking about discourse and discourse communities. So, what discourse means to me is basically communication and how we communicate in different settings. And I feel like this can lead into what discourse communities are. And from the PowerPoint that was presented earlier this semester, a discourse community is a place where membership is defined by specialized ways of talking, working, valuing, performing, and being, where language shapes and disciplines its members. So examples of this would include the banquet I just went to. It was pretty formal. I had to dress up. I wore heels, and there was a lot of formal talking. There was speeches being made, awards being given, stuff like that. Very fancy food placed out. Everyone was dressed up. Everyone was being quiet, using indoor voices. And basically, at a banquet, I'm not expected to put up my feet, relax, and just talk as I were to all my other friends. In our classroom for literacy, I find that sometimes I'll put my feet up, I'll laugh with my peers, I'll just say random things that come to my mind. But obviously if I'm at a banquet or any formal event like a wedding, I wouldn't necessarily be expected to do that, and so therefore I don't. So therefore I would talk and perform as I'm expected to, because that's just a different type of setting that I'm in. I'd probably do the same thing at a wedding, be as respectful as possible, try to act more professional. I'm not really taking the role as a friend or something like that, but I'm a guest at a wedding, so therefore I would have to act like a proper professional guest. And same for interviews. Another good example is in interviews. I go in as a professional. I present myself in a way that I don't talk to other people. I use different language. I express myself in different ways. I would never try to make the same jokes that I do with my friends or at school in an interview, because that's not the purpose of why I'm there. Of course, the way I act at school or at a banquet or a wedding may also be different how I am at the dinner table with my family. It all just depends. So those are different examples of discourse communities, and of course the setting that I would be in for all of those would basically change the expectations of how I'm supposed to act and talk to other people. What discourse does is it teaches that when someone speaks, reads, or writes in a certain way, that the person is taking on the values of that community. So basically, talk is linked to value. And school community values some type of works and not others. So therefore, students and teachers are supposed to act a certain way, and then other ways that people act may not be as valued or as accepted. And so teachers and students become certain kinds of people with certain likes and preferences and work ethics, and just the way they express themselves could be different to how they want to act or how they actually act in other settings. In terms of school activities, there are ways of being and exclude those that perform other activities. These values and activities, as demonstrated through language, define what counts as membership in content area classrooms. And a lot of that I got from the PowerPoint. So basically, when you're in school, you're supposed to act a certain way, you're supposed to be respectful, you're supposed to, ideally, just sit in your seat and do as the teacher instructs you. And then if anyone were to ever go past those boundaries of what is expected or what is desired, then automatically they are not going to be seen as the same, because they're not representing the values of that discourse community. Ideas of discourse inform teaching, schooling, and learning, because it just sets expectations for how people should talk and act. And discourse communities function in school in a way where it sets these expectations. People prefer other people by how they act, and it just sets kind of the boundaries and outline for how the school day goes between how people interact with each other. And then of course discourse functions in society by setting a maybe unconscious expectation of how you're supposed to act in different settings, which in general people learn very early on in their lives. Because if you start acting up in a way that's not expected, people usually try to correct you right away. Discourse communities aren't limited to just being in school. school can include a lot of different discourse communities. You have meetings between teachers, you have like different student-teacher relationships, and then you have the students talking with students, or students talking to people that they're not friends with, stuff like that. But also you have the discourse communities within certain disciplines. And the discipline that I'm going into and currently studying is mathematics. And there are a lot of different habits of mind and certain expectations of what it means to act, speak, write, and do things as a mathematician. Within the math discipline, there are many habits of mind that demonstrate being a member of the disciplinary discourse community. And it can be very similar between the different disciplines, or some of them can be vastly different. And some of these habits of mind include analyzing proofs, problem solving, breaking down problems, using certain language when describing math concepts, and recognizing the connection between certain vocabulary terms. It also looks at seeking patterns and seeing connections within problems, using logical explanations when explaining solutions, and making predictions based on how you approach a problem. And there are different ways that as a teacher, I can use certain curricular and instructional and assessment methods in order to help students develop this expertise in the subject so that they can approach disciplinary discourse communities in a way where they can present themselves as, like, you know, talking and writing like a mathematician. So one way that I can help students like develop the habits of mind of a mathematician really can start from just learning about the academic language and learning about the different vocabulary and practicing with it, and then going from there to develop skills in writing with the language and talking about the language and approaching problems with the language that's involved in it, or just the symbols and the terminology and stuff like that. So a lot of the vocab that is taught can basically go into content area knowledge and certain knowledge goals like definitions and terminology and stuff like that. That's also not just in math. That can go for all other disciplines. And a quote that I read by Zairis Ko states, and I think this explains things overall very well, is content area classrooms knowledge is co-constructed and reconstructed by discourse among teachers and students. And I think that's a really good point, because the discourse and the way that people speak in the classroom helps students develop like the understanding of how to use the words. And it all just comes from the discourse that's established between the teachers and students to make sure that the students can learn as much as possible with, learning all of those things. In order to establish habits of mind and to learn that content area knowledge, I think it's really important that students in any classroom should always have the opportunity to discuss, collaborate, and cooperate with other students, and they should also be problem solving in any case. And the problem solving can definitely have a direct relation to math, because that's a lot of what we do is just solve math problems. But also in science, like you're problem solving after doing an experiment, you can incorporate problem solving by how do we fix this situation? Like if we know that there's a lot of fertilizer that's getting into the water and we want to find a way to like eliminate this, but also like keep the grass nice and growing, like what's a way that we can approach this problem type of thing, or something like that. Other habits of mind and good skills to develop in order to think and talk and act like a mathematician go far beyond just like the general analyzing proofs and stuff like that, and problem solving and working directly with problems that are asked. It also involves how exactly we question, how exactly we write, and how exactly we communicate with others around us. So in terms of inquiry and questioning in math, is some of these examples can include just simply asking why. Why is this true? Why do we care about this? What application does it have in the real world? Another question that it's good to ask is the solution clear? If we were to write out this proof, or if we were to explain the answer, is it clear enough so that someone knows what our thinking is and can follow along with our logic? Another question to ask is, can we prove this fact? Is this a provable theorem? Has this been proved before? And how can we prove it? Can we prove it by assuming the opposite and then assuming that, and then getting to the conclusion that the opposite is false and therefore it has to be true? Are we going to approach the proof directly and make sure that we come up with enough examples to show that this is actually a true statement for all relevant general equations? So thinking about how to go about proving it, is this proof the most efficient and clear way to do so? And also it's important to just ask, and I do this still in college, do I understand what is being asked of me? Because sometimes when you look at a problem, you kind of understand what the problem is stating, but you're not exactly sure how to answer it. You don't sometimes know where to start. So it's important to sit back and ask yourself, do I understand what this question is asking? And then depending on yes or no, you approach what you need to at that point. In terms of writing, a really good habit to get in the groove of very early on when involved in the math discipline is learning to take really good notes. I've never once sat in a math class and just didn't write a single thing down. Even if I've kind of learned the topic before, I always find that I memorize it a lot quicker if I continue to write it. Keeping journals, I think this is a really good technique that I want to implement in my classroom. Students just have the freedom to write down in their journal what they learned, what they're confused about. And then I could collect those journals, not necessarily for a grade, but just to inform myself of, okay, this is what they're thinking about. Like, this is maybe what we should address tomorrow. Or, oh, this is what they're interested in. Or, oh, they have a really good grip on this, so maybe we could further their learning and understanding of the content. Of course, it's very important to write detailed steps and solutions to the problems that we're solving. Definitely, that expectation definitely does not end in high school. I still have to do it on every single exam that I take. And when you write proofs, that they are clear and logical, so that, of course, again, as stated earlier, the reader and whoever's reading it can at least follow your logic in clear steps. So in terms of communicating like a mathematician in that disciplinary discourse community, it's important to use mathematical language as we speak. So it's important to like use terminology. It's important to say things in a way that is understandable. Verbally summarizing is really important. Sometimes when you write proofs out, you have to go step by step to make sure that like everything is clear in logical steps. But it's important to like verbally summarize as you're explaining the material so that you're not taking up too much time and that it's obvious that you have a clear idea of exactly what the overall picture is. It's also important to express ideas clearly as they are also in the proofs and in the problems. And this is something I'm definitely still learning, is recognizing the different methods of proving that a statement is true or false. There are many different ways to solve a problem. Like there are many different types of proofs that prove why the Pythagorean theorem is true. A squared plus b squared equals c squared. And of course, some proofs are easier than others, but it's important that in general, especially in a secondary education setting, students will find different ways to solve problems. And it's important that other students hear how those solutions are. And it's important that we accept their ways of solving, because if you just shut down their methods, then it discourages them to, continue to do the work the way that it makes sense to them. So some curricular, instructional, and assessment examples that I want to use to support discourse community membership and help develop specific disciplinary habits of mine in my classroom is I plan on implementing project-based learning so that my students would then be instructed to kind of play the role of some figure that is involved in math, such as like a structural engineer who has been assigned to construct a blueprint for a playground that is being built in the local elementary school. And one thing they may have to do, bringing in the Pythagorean example again, is they may have to figure out exactly what parts of the playground they want to build, and they have to figure out, okay, like this shape involves right triangles, so therefore we may have to apply the Pythagorean theorem. And therefore, we may have to take into consideration Pythagorean triples. We may have to take into consideration right angles and the terms for the sides of the triangle, like the hypotenuse and the leg and the opposite side and the triangular prisms, perhaps, if you have to deal with the 3D shapes. You have to deal with different variables that you don't know, and then therefore you have to solve for the sides you don't know in order to construct other structures on the playground, etc. So basically, I would give students the opportunities to also talk about problems. Students may have to do the math with other people, and therefore they'd have to communicate to others, and then they'd have to write down the math. Then if they were to present the poster that they came up with, they would have to communicate to a larger audience using mathematical language and expressing ideas clearly and stuff like that. And then of course, as they're doing the actual math, they are analyzing the math that they're doing. They're analyzing, okay, how exactly do we approach this problem as effectively and efficiently as possible. So that's basically something that I think is really important that I really want to implement, especially as kind of like maybe an end of the year project or a larger grade that's maybe not as stressful as an exam. Additionally, I also want to give my students an opportunity to develop proofreading skills. Proofreading can be extremely stressful, and I didn't do a lot of this in my own high school experience, but I think it's really important that students kind of understand where theorems come from and why they're true. Bringing in the Pythagorean theorem example once again, there's different ways to prove the Pythagorean theorem, and I think a cool activity, especially with enough scaffolding and guidance, would be giving students the problem or the equation for the Pythagorean theorem, a squared plus b squared equals c squared. Telling them what the sides represent, what it means, and then saying, okay, why do you think this is true? And like maybe working with other kids, and then they can start drawing like the different triangles and seeing like maybe where the theorem came up. Or as a class, you can kind of develop the proof together type of thing. I think at least that minimum exposure can be very helpful, especially if this is something that students want to pursue in higher education. But I feel like activities like that give a lot more meaning to the content, and it makes students perhaps care about it more and have a better understanding of like why stuff is the way it is and why it matters. So in conclusion, I think that just acknowledging discourse and the different discourse communities that are in school and in society is just really important to at least recognize, and understanding like how it shapes behavior and different styles of communication. Especially in the math world, discourse is very important, and I think that it's important that as teachers, no matter what academic discipline somebody is in, it's important to try to have them develop the habits of mind and skills in order to approach those discourse communities in the future.